Good morning, everyone. Hopefully, everyone is having a magnificent and marvelous Monday thus far. It is 11 o'clock and we are getting it in. Okay, today is Monday, June 1st. So, to all my people, it's the first of the month. I'm not going to sing the song, but you know what I'm saying. All right, and today we are going to be talking about, or we're going to be reviewing rather, inequalities. Now, remember, inequalities are simply equations that are not equal to each other. That's all inequalities are. And I have a ding, so let me acknowledge who has just joined me this morning. Good morning. I thought I heard a ding. Good
Good
morning.
morning, Miss.
Oh, good morning, Mr. McFadden. How are you?
I'm good. One day at a time.
Oh, absolutely. Don't I know it? All right. Well, you just came in at a good time. I just started recording, so you're good. We are going to be talking about inequalities this week, and next week it will just be a conglomerate of potlucks, basically. But we'll talk about that a little later. But in essence, just this week, I want to review inequalities with everybody, just making sure that you know the different signs, what they mean, how to recognize them, how to graph them, how to solve them, everything as it relates to inequalities. And I will say this, if you know how to solve equations, inequalities will be no problem. And I'm going to prove that momentarily. But before we begin, I want to do a mental Monday check-in. Despite what's been going on and what's been happening, I want to make sure that everybody, even the students that are here and the people that are watching the playback, how are you? So, Mr. McFadden, how have you been feeling? How have you been doing, given the circumstances of what's been happening, not only within our state, but just beyond the world? How are you feeling?
Um, been been feeling pretty good and kind of confused and overwhelmed by everything. I mean, it's
Mm,
it's pushing us back as people. I feel like so. You know.
mm. I can definitely understand. And my sentiments are is I agree with your sentiments. I'm just going to say this because I don't want to, prolong our lesson. Um, I did a video. I think it was Friday. Yeah, last Friday. So if you have not watched that video, go and check that out. But it's basically going to sum up how I was feeling. I will say that I'm in a better headspace today. I'm in a better mood, so to speak. The past couple of days, when I made that video, I was just out of it. I honestly wasn't myself. And sometimes we I don't know. We go through a lot. We deal with a lot, and then something else happens, and it's just like, really, like I'm already dealing with this, and now I gotta add this to my plate. So again, I just want to encourage you all. Please go and watch that video. It's called "A Word from Your Favorite Nerdy Educator." I think I'll probably leave a tag or something in the within the video or the link. It is an encouraging word, and I actually looked at it before I started this lesson because we have to encourage each other. That's very important, and I want to make sure that all of us are in a decent headspace to where we can focus on these lessons and get everything that we need to get, so that way we can be ready to take these tests and just knock everything out all in one big whop. So again, I just want to encourage you all, if you're watching this playback video, despite everything that is going on in the world, continue to encourage yourself and continue to encourage other people. Each one teach one and each one reach one. So, my prayer is that we can come up with a solution to these issues, to these problems. I just pray that we can make each day better, not only for ourselves, but for our children and for future generations, for the legacies that we leave behind. So I'm just praying for a better day and a better way. And as Mr. McFadden always says, one day at a time. So that's what we got to do. We just got to take it one day at a time. All right. So enough of my sermon for the day. Let's go ahead and get started with these inequalities. All right. And of course, I'm going to make this bigger because I can't even see it. Y'all know I can't see. All right. So I want to, let me see if I can make that. All right. So that's probably too big, but hopefully you all can see that. All right. So let's start off very quickly by reviewing what an inequality is. So let me pull up my toolbar here. I'm going to put it over here for a quick second. And yeah, I know my favorite color, blue. All right. Wow. So I want to look at this word, inequality. That means not. So when we say incomplete, incompetent, we are saying not competent, not complete, right? So that's a prefix. And the word equal. So in essence, an inequality simply means not equal. That's all it is. All right. And as you can see here are the inequality signs. And let me move this over just a smidge. Hopefully y'all can. All right. Hopefully y'all can see that. All right. So we have the greater than sign. We have the greater than or equal to sign, the less than, and the less than or equal to. Now, let me say this. Inequalities, again, simply means not equal. When we learn how to compare numbers to see which number is bigger, which number is smaller, I was taught whichever the mouth of the shark or the fish, or some people learn alligator, whichever way wherever the larger number is, that's where the mouth of the shark, the alligator, or whatever is going to be open at. So very quickly, just a quick example. Okay, so we know that 5 is smaller than 7. We know that. But because 7 is bigger than 5, we are going to open our shark mouth or whatever, our greater than, our less than sign to the 7. So we would read that as 5 is less than 7, because that's a true statement. 5 is less than 7. Now, of course, if I had this, on the other hand, 7 is bigger than 5. We know that. So this would be read as 7 is greater than 5. Simple. So just think of it this way. When we're dealing just with numbers by themselves, and I have a practice sheet that we're going to do a couple of those together as it relates to graphing. You want to make sure that the mouth is open to the larger number. So if the number is on the left, then it's going to be a less than sign. If the larger number is on, if the larger number is on the right, excuse me. So this is my right, I'm sorry. So if the larger number is on the right, it's going to be a less than. If the larger number is on the left, it's going to be greater than. So again, my apologies. I was looking at this one and I meant, you know what I meant. Okay. So anyway, so now I want to scroll down and talk about these greater than or equal to or less than or equal to. All right, so it says the line underneath the greater than sign indicates also equal to. So we're going to be seeing examples of those when we solve inequalities, okay? Same thing with less than. The line that is under the less than sign, it indicates also equal to, okay? So again, you have your signs, your greater than sign, your less than sign. They don't have a line under there, okay? So that's just regular schmegula, what it is. Your greater than or equal to and your less than or equal to, they will have a line under there to let you know that it also means equal to. And again, I'm going to show you and review with you what that means as it relates to graphing. Okay, so Mr. McFadden, you are the only one here as of right now. So if you have any questions about anything, feel free to jump in. Okay. Now, when it comes to, and I'm going to, okay, there we go. Hopefully you all can still see that. When it comes to graphing inequalities, okay, this is where I think a lot of my students, they do a very good job with solving inequalities. Is when they get to the graphing, it's kind of like, So again, I just want to do a couple of practice problems just to show you how to graph inequalities. Now, again, if you know how to solve an equation, you can solve an inequality, and I'm going to prove that momentarily. But I want to look at these graphing inequality symbols very quickly. Okay, as you can see here, we have what's called an open circle and a shaded circle. Some people say closed circle. It just depends on, the terminology. Okay, so this open circle indicates that this is not equal to the number that is graphed. Okay. The greater than or equal to is going to be closed or shaded in. So that lets you know that your answer is included as a solution. Okay, so when we start graphing inequalities, you're going to have multiple answers, actually. Basically, you are going to have multiple answers. And when we say that the greater than or equal to, that means that answer is included as a part of the solution, versus with the greater than or less than, the answers are not included as a part of the solution. Okay. With the greater than or equal to and the less than or equal to, the answer is included as a part of the solution. Okay. So I do have this as a PDF file. I will be sure to email it to my students, and I will also leave a link in my pinned comment section. So if you would like to take a gander at this and have it as a hard copy, feel free. There are some other pages that went along with this. This was like 6 pages, but I wanted to focus on this particular page because the other pages deal with the different properties as it relates to the operations, adding, subtracting, multiplying, and dividing with inequalities. Okay. Now, I will say this. When we get to multiplying and dividing negative numbers as it relates to inequalities, you have to do you have to do one thing, which is basically flip the sign, but we'll get into that momentarily. Okay. So I just want to make sure that everybody, has an opportunity to watch this. If you're watching this as a playback video, you can pause this, take your notes. You can use this and work this at your own pace. Okay. Now, all right. So, Mr. McFadden, you feeling okay?
Yes.
All right. Just wanted to be sure. Just wanted to make sure that you're still with me. And thank you again for your consistency. I really appreciate you. All right. So now what I want to do is I want to open a new page. I'm going to pull my toolbar up. All right. All right. All right. Make sure I had it wrong. All right. So an equation is simply put is what you solve. Okay. So I'm going back to regular schmegula equations right now. No fancy dancy, none of that. And an inequality, again, is something that's not equal. All right. And they use the inequality signs. They use the less than sign, the greater than sign, the greater than or equal to sign, and the less than or equal to sign. Okay, so with equations, remember, always going to be equal. That's what equations are. Inequalities, they are going to use those signs that we just saw. So you got the less than, the greater than, less than or equal to, and greater than equal to. Okay. All right. All right. Mr. McFadden, I have a question for you. How would I solve this particular problem? And if you don't remember, you can just say, Miss Hampton, I don't remember.
You had to move the 16 to the left
Yep, but how do I do that? You're right, but how do I do that?
by 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 subtracting 16 from both sides.
Not 16. You do subtract something, but it's not 16.
The
So
7 from both
yeah,
sides.
you subtract 7 from both sides. I'm going somewhere with this, so if you're watching this as a playback video, stay with me. So I have m is equal to 9 because we know that 16 minus 7 is 9. Okay. Now, what this is saying is there is no other number that I can put in place of m that is going to yield me 16 if I add it to 7. The only number in the United States of the galaxy of mathematics would only be 9. Okay? That's the only number that if I put it in place of this m, 9 plus 7 will give me 16. Okay? So I want you to remember that. Okay. So, Mr. McFadden, how would I solve that inequality? And if you don't know, just say, Miss Hampton, I don't know.
I don't know that.
Mm. You are going to flip your wig when I tell you how to solve this inequality. You're going to be like, really, Miss Hampton, that's all I had to do? Now, Mr. McFadden, I want you to follow me here. You told me that I have to subtract 7 from both sides to get m equals 9, right? That's what you said, right?
Yeah, yeah.
All right. I'm going to do the exact same thing. I'm going to subtract 7 from both sides. My answer now is going to be m is less than 9. Now, I know what you're thinking because I've, like I said, I've been doing this a long time. Miss Hampton, that's all I had to do? Yeah, that was it. Remember, and I can't stress it enough, math is one of those things that's repetitive. So if you can solve an equation, you can solve an inequality. I didn't deviate. I didn't do anything different. The only thing that has changed, instead of me having an equal sign for an equation, I have an inequality sign. But the rule is still the same. So that's why I have been stressing to my students, know the process of how to do certain things because you're going to see it again, but it's just going to be in a different format. But the rule is still going to apply. So again, if we know how to solve one-step equations, we know how to solve one-step inequalities. Does that make sense, Mr. McFadden?
Yes.
Okay. Now, the answers are, of course, different because, again, we have, where's my cursor? Okay. We have M equals 9. So that means 9 is the only answer that I can substitute back in for M that would make this entire equation true. As we look at this inequality, this is saying that M is less than 9. So what does this mean, Ms. Hampton? Well, inequalities have multiple answers. So as long as I find a number that can satisfy, if I were to substitute it back into the original equation, it can satisfy that particular inequality. So Mr. McFadden, give me a number that is less than 9.
7.
7. Okay. So I am going to put 7 in place of M. So in essence, what I've done is I'm just substituted, right? So this is true. 7 is less than 9. That is correct. I am also going to show you what that would look like if I were to substitute this number 7 back into the original equation. Okay, so I have 7 plus 7. And what is 7 plus 7, Mr. McFadden?
14.
14. Now, is 14 less than 16?
Yes.
So therefore, 7 would be a solution to that inequality. Okay, I could have picked -3. So again, we dealing with these integers. You can't get away from it. You have to make sure, again, that you are very strong with your integers. I also have a fundamentals of math playlist where I talk about the foundational groundworks for advanced math, but it's basically pre-algebra in a sense. So please make sure that you watch those videos to make sure that your foundational groundwork for advanced math is strong. Okay, so 7 is a solution. 8 is a solution. Why? Because I know 8 is less than 9. But what if you were not sure? Okay, what if you say, well, I don't know what number was what, so I'm going to pick another number. Mr. McFadden, give me a number that's greater than 9. I'm going somewhere with this.
12.
Okay, so my original equation was M plus 7 is less than 16. And let's just say again, for instance, you're like, well, I don't know what number would work there, right? So you follow the rule. You say, okay, I subtract 7. Okay. All right. Now, you said 12. So I am going to put 12 here because you said you picked the number and it's 12. Now, we know that 12 is not less than 9. We know that. So because 12 is not less than 9, that would make this inequality not true. And because it's not true, 12 would not be a solution. Is it safe to say that we can agree with that?
Yes.
All right. Now, another way again that you can check yourself to emphatically be sure is to put 12 back into this original equation. So that's what I'm going to do. I'm going to say 12 plus 7. Now, 12 plus 7, the last time I checked, was 19. And the last time I checked, 19 is not less than 16. So again, when I put my numbers in back into the original equation just to check my work and to make sure that I didn't make any mistakes, or that I, just followed everything correctly. This is not true. So therefore, 12 would not be a solution to that inequality. Does that make sense?
Yes.
Okay. Now, this is where I get beat up. This is the part where, Miss Hampton, I really don't get it. But in due time, you will get it because this is easy. This is where we get to graph the equation. Now I'm going to go back to the first page because that's this is the right answer right here. Okay, so I am going to graph this. Okay, now I'm going to go ahead and use a different color. I'll use red. Okay. Now remember, with number lines, your negative numbers are to the left, your positive numbers are to the right, and smack dab in the middle, you have 0, which is balanced. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then I'm just going to put a couple of marks over here on the negative side. And remember, my number line is not drawn to scale, so please do not laugh at it because I'm very sensitive. All right. So on the regular number line, you'll have your numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you'll have -1, -2, -3, blah, 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 blah. I'm going to the left. Now, I am going to go ahead and show you how to graph this. So I'm going to put a little arrow. These two go together. All right. So what you're going to do is your number line, when I give out worksheets and things like that, more than most times, the numbers are already listed on the number line. So you don't have to, write any numbers in. So what I'm going to do is I'm just simply going to count to 9 from the right because my 9 is positive. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put the number 9 here. All right. Now, the next thing I have to do is I have to look at my sign. I have to figure out if I have an open circle or a closed circle. So because this is simply saying less than, that lets me know that I have an open circle. Okay, so again, I want to go back here. And hopefully you all can, can see that. But if not, let me make it a little bigger. Just a smidge. All right. So remember, when I have a greater than sign or a less than sign, I have an open circle because the open circle indicates that this is not equal to the number that's graphed. In other words, 9 is not a part of the solution. It doesn't count. Okay, so I'm going to go back here, put you down here. All right, so, all right. All right, so I'm going to do an open circle above the 9. The open circle again lets me know that 9 is not a part of the solution to my inequality because 9 will never ever be less than 9. Now, if this was less than or equal to, then my circle here would be shaded. But because I don't have a line under there, it's just a regular inequality, which is the less than sign. I have an open circle at the top of my 9. Now, after you do that, you now have to determine which way am I going to shade my solutions. Is it going to be to the left or is it going to be to the right? This is where you do what we did here. You're going to pick a number from your number line. Now, if you're not as comfortable with integers as you feel that you should be, always stick with positive numbers. So for the sake of time, we are just going to stick with what we have here, which is 7. So 7 is less than 9. We proved it right here. So if 7 is less than 9, that means 8 is going to be less than 9, 6, 5, 4, 3, 2, 1, 0. Any number that's to the left of 9. Any number, any fraction, any decimals, anything. So what you're going to do is you're going to draw an arrow, because remember, lines go on for forever. Okay. And this is me scribbling all the solutions. Okay. All right. So again, the rules are this. When you solve your inequality and you have your answer, what you're going to do, you are going to, on the number line, you are going to use your answer, graph your answer first, determine if you have an open circle or a closed circle. Make sure that you look at the signs. That's going to be very important. And then you can pick a number to determine whether or not you go to the left of your solution or to the right of your solution. Okay. So what I want to do now, I want to just do a couple of practice problems without solving. These are just basic, regular schmegular inequalities. Let's see. All right. I'm going to make this bigger. Uh-oh. Okay. All right. Hey, Mr. McFadden, can you see the screen? Is it big enough for you?
Yes.
Okay. Wonderful. All right. So we're just going to do numbers 1, 2, and 3. And do not worry, I will be emailing you this worksheet so that way you can have it and you can practice on the graphing part. Okay. So no worries. I got you. All right. So let's look at. Oh, I'm sorry. You had a question?
No, I just said thank you.
You're very welcome. All right. So let's look at number 1. Number 1 says 5 is less than or equal to. So we see that line under there that lets us know equal to Z. Okay. So again, this is my less than. And the way to remember the signs, because I know when I was younger, I would actually get confused with the signs. I didn't. So the less than sign looks like a slanted letter L. So that's going to let you know that you have a less than sign. Number 2 is a greater than sign. Okay, because it's going the other way. So remember, the less than sign looks like a slanted letter L. So this is my less than or equal to, because I have that line under there. And I'm going to underline that. Okay. Now, because I have this less than or equal to sign, Mr. McFadden, can you tell me if I have an open circle or a closed circle?
Far as
I'm sorry?
you said, open circle or closed circle.
Yes.
I'm not sure, Miss Hunt.
Okay. Okay, so we're going to go back to our sheet here. And by the way, everybody, again, all the information and resources, if you're one of my students, I'll email it to you. If you are watching this as a playback video, I will leave it in the pinned comment section for you. All right. So I'm going to go here. Uh-oh. Let me go back up. All right. So because I have a less than or equal to sign, right? So this is the sign that I have for number 1. So because I have that sign, I'm going to scroll down here And that's going to let me know that I have a closed circle, okay? So it says the closed circle indicates that this is the equal to the number that is graphed. So when I go back to number 1, all right, so when I go back to number 1, I have a shaded circle or a closed circle. And I'm going to put that closed circle above my number 5. Okay. So that is letting me know that 5 is a part of that solution, because 5 is less than or equal to 5. 5 is equal to 5 all day long. So that's the reason why we have that closed circle or the shaded circle, simply because 5 is a part of that solution. Now, of course, the next part is we have to figure out, are all of my solutions to the left of 5, or is it to the right of 5? Okay. So, Mr. McFadden, I want you to pick a number. We got 0 through 14. I want you to pick a number off this number line.
10.
10. Okay. So now I'm going to substitute 10 in for Z, because remember, in inequalities, you can have multiple answers or multiple solutions. Is 5 less than or equal to 10? Is that true?
No.
So 5 is not less than 10.
Yes, it is. Yes, but it's
Oh,
not equal to.
okay. I'm glad you mentioned that. You know what? You must have been reading my mind. I'm going to tell you why I said that. When we say less than or equal to, we're not separating them. So it's one big entity. Okay. I understand a lot of students. I had one student said, I don't know if it should be less than or equal to, because we understand the word or denoting a choice. But in this particular instance, it is all one entity, meaning that my answer is going to be less than or equal to whatever the other number is. So I'm going to go back to 5. So let me ask you this question, Mr. McFadden. Is 5 equal to 5?
Yes.
Okay. So because 5 is equal to 5, we know that it's not less than 5. We know that. But we know that 5 is equal to 5. So because 5 is equal to 5, we have this line under here. So remember, when you have an inequality sign with a line under there, that lets you know that it's going to also be equal to. So 5 is less than or equal to 5 because 5 is equal to 5. Does that make sense? Yes, no, sort of, kind of.
Yeah, a little bit.
Okay. So remember, and again, I understand because I overthink a lot too, but don't overthink this. um Less than or equal to is not, you don't pick one or the other. When it says greater than or equal to, that's one entity. They're united front. Okay, so that means they are going to be together, so don't separate them. Okay, so you don't have to pick, is this one less than or that's not what they're asking. So I just want you to keep that in mind. But back to this number 10. So, Mr. McFadden, if I had $10 and you had $5, who got the most money?
I do.
Okay, I'm gonna say it again. If I had $10
Oh,
and
you
you had $5, who has the most money?
you do.
Okay, remember that. So 10. So keep that in mind. 5 is less than 10 because you have less money than me. Correct?
Mm-hmm.
So because that's a true statement, it's true. I have more money than, well, just for the conversational purposes, but I don't know what you got in your bank account. Ain't none of my business. But what I'm saying is for the intentionality of this conversation, 5 is less than or equal to 10. So that's a true statement. So 10 is going to be a part of my solution. So if 10 is a part of my solution, that means 9, 8, 7, 6, and 5. The reason again that 5 is included is because we have this line under our inequality, and that means equal to. Okay. Now, I'm going to ask you another question, Mr. McFadden. If you had $5 and I had $3, who has more money? You or me?
I do.
Okay. So so stay with me. 3. Is 5 less than or equal to 3?
No, it's greater.
Exactly. So because it's greater, that means any number to the left of 5 would not be a solution. So 4 is not a solution. 3 is not a solution. 2, 1, 0. None of those numbers are solutions. But everything to the right of 5 would be a solution. So 11, 12, 13, 14, 5,367,000, which is not on there, but remember, lines go on for forever, would be a solution. All right. And this is just me scribbling all of the solutions. And when I say all of the solutions, I am including the fractions that you don't see. I'm including the decimals, which is another way of writing fractions. So all of that is included in there. Okay. All right. So now I'm going to switch colors here. All right. So now let's look at number 2. This is red. This particular inequality is read as F is greater than 2. So this sign is the greater than sign. Okay, so this is my greater than sign. Now, how do we graph this? Okay, Mr. McFadden, I want you to pick any number off this number line, any number. Well, I'm sorry, before you pick any number, excuse me, do I have an open circle or a closed circle? Now, because I just have a regular greater than sign, that means I have what kind of circle? Open or closed?
I would have to see it again.
Hmm? I couldn't hear
Close,
you.
close circle.
Closed circle?
Yeah.
Okay. So I want you to look at number 1, and I want you to look at number 2. Does number 2 have a line under it like number 1?
No.
So because it doesn't, that lets you know that we have an open circle.
Okay.
Okay. But this is good. So you're doing good. So I'm going to make an open circle under my 2 because that's the number. So whatever number you see, you're going to make your open circle or closed circle above that number. Okay, we got to get that out the way. All right. Now I want you to pick a number off the number line, Mr. McFadden. Any number at all.
3.
3. Okay. And that's cool. You keeping it safe. I like that. All right. Is 3 greater than 2?
Yes.
Yes. So because 3 is greater than 2, that means 4 is a solution, 5, 6, 7, all of these numbers that I'm checking would be a solution. Why? Because these numbers would make the inequality true. 14 is greater than 2. 13 is greater than 2. 10 is greater than 2. Okay? Now, I am going to pick 0. You can never go wrong with 0. Is 0 greater than 2?
No.
So because 0 is not greater than 2, that means any number to the left of 2 on my number line would not be a solution. So 1 would not be a solution. 0 would not be. Technically, 2 wouldn't be either because I don't have that equal to sign under my inequality. Okay, so all of the numbers again to the right. Ooh, would make that inequality true. So 3.5, 9.75, 13 halves, which is 6.5, 15.7, all of those numbers, decimals and or fractions, would make this inequality true. Okay. Now, do not worry. We are going to stay on this all week, simply because I was told that there were a lot of these on your math GED exam. So why not? Let's just knock it on out, right? All right. So how do you feel so far, Mr. McFadden? Do you feel okay?
Yes, ma'am. We're getting there.
Okay. All right. Just wanted to, do a little check-in, make sure you was all right. All right. Oh, well, look at there. I like number 3. And I'm going to switch colors again because that's just kind of what I do. Yeah, let's go back to good old blue. Now, number 3 is a decimal. Now, before we, be like, oh my God, we got decimals and fractions. Um, decimals are just another way of writing fractions. Fractions is, you can write fractions as a decimal and decimals as fractions, okay? Don't be intimidated by what you see. I'm not deviating away from anything. The only thing that's different, instead of me having a whole number, I now have a decimal. No biggie. Now, Mr. McFadden, I have another question for you. This is negative 2.5. So I want you to tell me, where would negative 2.5 be on my number line? Because you don't see it. But tell me, where would it be?
Between a -3 and a -2.
Yep, exactly. See? No biggie. So I am going to put negative as best as I can, negative 2.5. All right. So remember, when you're dealing with decimals and or maybe fractions, they're not always going to have them labeled. So it's going to be up to you to know where they fall in as it relates to the number line. Okay. Now, y'all, that says 2.5. I just want to put that out there. Now, this is a good one because we're now dealing with a negative number. So it says 2.5 is less than G. We already labeled our negative 2.5. And now, Mr. McFadden, I ask you, do we have an open circle or a closed circle? You still with me?
Yes, ma'am.
Okay. Do we have an open circle or a closed circle above our negative 2.5, excuse me?
A, op- a open circle?
Very good. We have an open circle. Do you remember why it is an open circle?
No.
Okay. So this is where I want you to make the connection. The reason why we have an open circle is simply because there is no line under our inequality sign.
Okay.
Now, I don't know what this extra line, I guess that's just where the answer is, I guess, but that's, yeah. So again, if we look at number one had a line under the inequality. Numbers 2 and 3 do not. So remember, when you have no line, like numbers 2 and 3, you have an open circle. And I know okay. Number 2 kind of looks closed, but it's not. And if you have a line under your inequality, like number 1, then you have a closed circle, okay? All right. So now this is the fun part. I want you to pick a number on the number line, Mr. McFadden, any number at all.
6.
6, okay. Well, even though 6 is not on this particular number line, but we can still use it. Okay. So I have a question. Is negative 2.5 less than 6?
Oh, I'm sorry about that, man. Hampton. I had went to number 4. That's why.
Oh, okay. Okay. Well, I mean, we gonna get there. I got you though.
Can you repeat the question?
Yes. So I want you to pick a number off the number line for number 3.
Okay. 2.
2. So my question was, is negative 2.5 greater? I'm sorry, not greater. Is negative 2.5 less than 2?
Yes.
It is. So because it is, that means 2 is the solution, 2.5, 3, 3.5, even though it's not listed. All of these numbers would be a solution. Now, I know what you're thinking, Ms. Hampton. You checking off the negative numbers. Why are you doing that? Because they're a part of the solution too. Ooh, my lines are so crooked. I'm sorry. All right. All right. So any solution, whether it's a decimal or a fraction, would suffice as any of the answers. So I could say negative 2.5 is less than 0. That is true. Negative 2.5 is less than 3.5. That is true. Now, I am going to pick negative 4, even though it's not. No, I'm sorry. That's 3.5. I'm sorry. Let me pick negative 3. And I'm going to say this, and I'm probably going to end it with this, and we'll pick this back up tomorrow. Matter of fact, let me open up another, because I really want to make sure that we understand how all this stuff works. All right. Okay. Why did you do that? Okay. All right. All right. All positive numbers are greater than negative numbers. All negative numbers are less than positive numbers. This is where a lot of people get it really confused. So I want to explain this as best as I can because we are running out of time. But I want to make sure that we understand again how integers work. When you are comparing two negative numbers. Now, this is the key. All positive numbers are greater than negative numbers. I'm going to prove that right now. Matter of fact, let me write it up here. If I had 7 and negative 5, 7 is greater than negative 5. All negative numbers are less than positive numbers. So if I had negative 5 and 7, negative 5 is less than 7. That's true. When you are comparing two negative numbers, the number that is closest to 0 on the number line is the greater number. Okay, Mr. McFadden, you still with me?
Yes.
Okay, give me 3 minutes and I'll give you the rest of the day, I promise. What number is bigger? Now, these two numbers are positive, so I have 7 and 5. Which number is the bigger number?
7 is greater than 5.
Yes, 7 is greater than 5. Okay. What about now? I have negative 7 and negative 5. Which number is bigger?
It's negative 7 is less than negative 5.
So therefore, negative 5 is the bigger number.
Yes.
And it's the bigger number because, very quickly,
It's closer to 0.
because it's closer to 0. See, I don't even have to draw it out, do I? Well, I'm going to draw it out because I already started. So I'm just going to put negative 7 here. That'll be 6. This is negative 5. 4, 3, 2, 1, and 0. Okay, and all these other numbers are positive. We know that. All right. So if I look, because I understand that I'm a visual person, and so got to give y'all a visual. If I were to see these numbers on the number line, I have to look at the number that's closest to 0. So negative 5 is closer to 0. So because negative 5 is closer to 0, that is what makes it the larger number. So remember, in the positive world, this is true. In the negative world, this is true. Because again, a lot of people say, oh, negative 7, oh, that's the bigger number. No, that is not the case. The number that is closest to 0, if you're dealing with two negative numbers, that number would be the larger or the greater number. Okay. So I'm going to end it here. And what I'm going to do is I am going to email you this same worksheet, Mr. McFadden, so that way you can just practice graphing. And we will go over a couple of these tomorrow. And then what I want to do is start working on the one-step inequalities with graphing and two-step inequalities for graphing and graphing the inequalities. And then we just on Thursday put a pretty little bow on it and just knock it on out. Okay.
All right. Sounds good.
All right. So how do you feel about today's class, Mr. McFadden? Being as how I think you're the only one here today, which again I appreciate.
Yeah. It was good. Learned a lot.
Okay. And I can go ahead and tell you this the next 2 weeks, because remember next Thursday is my last day teaching last day teaching. we are just going to, like I said, we're going to work on this all this week. And then next week, I just want to, tighten up any, any loose knots that you may have as it relates to any math. So I think next week, more than likely, will just be a week of potluck. So go ahead and get any concepts that you're still having trouble with, get those together. Because I think next Monday, that's how we're gonna do it. Okay, but for this week, we are just going to be doing the inequalities.
Okay.
All right. So again, I really do appreciate you, Mr. McFadden, for your dedication and coming to class. And hopefully you're getting some stuff out of this, which I'm pretty sure you are. Again, if you have any questions, you know where to find me. I ain't really going nowhere. But again, to anybody that's watching the playback video, please be careful. Please be safe. Um, that's my alarm going off. Be careful, be safe. I will be sure to leave all the resources from this video in the pinned comment section for your printing and note-taking pleasures. All right. So again, with that being said, Miss Hampton loves you. There's absolutely nothing you can do about it. And until tomorrow, bye.